So you've got a histogram of earthquake magnitudes. What's on the x-axis? X. Which one of those is the x?
Magnitude.
Magnitude. Good. What's on the y?
Percent.
Percent. So magnitude tells you how strong the earthquake is. I'm sure you know that already. But it'll tell you here how strong the earthquake is, and then the percent or number of earthquakes that are at that magnitude, right? So we've got kind of a distribution here that looks like what? So if you kind of trace over this here.
It is right skewed.
It is right skewed. Why is it right skewed?
Because it goes to the left.
Because the hump's on the left, the peak is on the left, the long tail is on the right. So this is a right skewed distribution. So your shape is right skewed. Okay, so it's off to the side. If it only has one peak, what do we call that?
Symmetrical.
Oh, no.
No, wait, unimodal.
Unimodal, very good. So when it's got one peak like this is called unimodal. Beautiful. Okay, so we know it's right skewed. So in your notes, you should be looking at the one that looks like
Right skewed.
right skewed. Okay, so look at that one. This is going to tell you everything you need to know right here. So it says, which measure of center would best describe the data, the mean or the median? How do I figure out which one I should use? Ava, what do you think?
It's median.
Why?
Because it says it in the notes.
It says it in the notes, right? It says it up here. The median is less than the mean. It also says down here, this little chart is going to be your best friend right here, this little chart. It says, is the data symmetric? Yes or no?
No.
No. So you follow the no. Then it says the median would best describe the center. That's the first thing it says. So you're going to use the median to describe your center. Median. Okay. What is the center of your distribution? So now go back to your picture here. The mode is the one that's all the way at the very top. It's the highest part of the peak. What number is your mode at the highest part of the peak?
2.
No, 19.
Yeah, so it goes, yeah, about 19 right up here. Yeah. Okay, so when we go down, right about here, what do you say is about the center of your distribution?
Like 2.
You could say about 2, you could say 1.8, 1.9, something close to 2. So your center of your distribution, I'm going to say is about 2. Ooh, that's not very nice. About 2. So your magnitude, your center is at about 2. Last one is, how would you describe the spread of your data? What should you use to describe the spread? Look back at your paper here. It'll tell you right in it, in your little chart. What should I use to describe the spread? Look here, the answer's here. The IQR, the interquartile range. So to find the spread, you find the largest number, and then you subtract the smallest number that you have, and that'll give you your spread. So what's the largest X value that you see?
5 or 6.
5.
Can you repeat the question?
It's 6. Oh, it's like so. That's
You
like
see that little thing over there?
7.
Yeah, we'll say that's about 7. So 7 is the largest. What's the smallest you have?
0.
Oh, the smallest you have is over here. It's 1, right? So your spread is going to be 7 minus 1. So your spread is 6. Good. All right. I would definitely write those words down. Spread. I would write that word center down, right? If you don't have those words written down next to it, write that. And if you don't have a cute little sketch drawn, draw a quick little sketch. Okay, we're going to do a lot of questions like this. Questions so far? Comments or concerns? Are we ready to finish up this packet?
Yes.
Yes. Okay, so we are on the 3rd page. We're on question number 2. I asked you to start trying to do number 2. I don't know if we did number 2. I asked you to try it, didn't I?
You did it by yourself.
You did it by yourself, yeah. So we did the first graph together.
Yes.
The hope was that you finished the second graph by yourself. And I'll tell you right now, this looks exactly like your warm-up question. So even if you didn't answer it before, right now you should be able to answer it pretty dang easily. What's going on here? and
Now, don't you agree is 10.
Oh,
10, then for a, you put like a middle 4.
all right. So let's finish up this packet today, because if we get everything done with this today, then tomorrow's gonna be you're gonna like it. Tomorrow's gonna be way more chill. Okay, so we are on this second one here. We did the graph 1. We did this one, and I asked you guys to do graph number 2. Okay, so who can tell me the first one there, 2A, which says, how do the shapes of the two graphs compare? What can you tell me? Reese, what do you think? Or sorry, not Reese. Oh my gosh, Hudson, my bad. I'm looking at you, sorry.
C and D are symmetric.
Both C and D are symmetric. Perfect. So C is symmetric. I'm just going to put SYM if you don't mind. C is symmetric and D is symmetric. Now, I know it doesn't, it talks about the shape. I don't think it actually says spreads anywhere. So let's look at the spread really quickly. Even though I didn't have you do it, let's look at the spread. If you look at spread C, right? So your spread is the smallest that you have and the largest that you have. So if you're looking at letter C, what is the spread for letter C? From where to where? Where does it start? Where does it end? 0 to 10. So what's your spread for distribution C? 10. Good. So for C, your spread is 10. How about distribution D? What's your smallest for distribution D?
5.
About 5. And what's your biggest? 15. What is that spread?
D, it's
10 again.
oh,
So what do you notice about those two spreads?
they're the same.
They're exactly the same. Very good. Which measure of center would best describe the data? So should I use the mean or the median? Mean. Why?
Symmetric.
Because they're both symmetric. Yeah. So because both of them are symmetric, to describe the center, I'm going to use the mean. Mean for both. Because they are symmetric.
Did something freeze?
Hey, it froze. It's my computer freezing. 1 second. Thank you. Thank you. Okay, so letter B, both of them are symmetric, so we use the mean. Now, the centers. How do the centers of the two distributions compare? What is the center of C? I'd say, yeah, it's a little off, but you can say the center is about 5. So I'm going to put an approximate sign. My center is at about 5. What is your center for distribution D? Your centers, yep, it's right about 10. Actually, that one's perfect. That one's on 10. So which center is the bigger center? Distribution C or D? D. So I'm going to write distribution C is less than distribution D. Right? It's smaller. The center's smaller. So where it's located, it's further over to the left than the right one. Okay, last part. Determine whether each statement describes graph 1, graph 2, or both. So this right here is graph 2. The one up above it that we did yesterday, that is graph 1. So letter A says, there is a difference between the typical data values of the two sets. So typical just means the mean. The mean. Typical means the mean. So if we're looking at the first graph, what is the mean for distribution A? What's your center? 7. What's your center for the second distribution? 7. So are those the same or are they different? They're the same. Okay. What about your centers are at the same number, right? They're both at 7. If you go to the second graph, are your centers the same?
No.
No, they are different. So which one has the difference, graph 1 or graph 2? Graph 2. Good. The mean and the median of the two data sets are the same. The mean and the median of the two data sets are the same. So if we go back to our little picture over here on the other side, your mean and your median for a symmetric graph are at the same number, right? They're at the same center. So which one of those has the same center? Graph 1 or graph 2? Which one has the same center? Graph 1. There you go. So your answer there is graph 1. The centers are at the same spot. Okay, last one. The mean of one set of data is greater than the mean of the other set of the data. Which graph has different means?
2.
Graph 2. Yep, our centers, those are our means. They're at different spots. So that's graph 2. There you go. You have now figured out distributions. Not too hard, right? As long as you have this page, and as long as you have this little thing right here, you're golden. If you lose this page, you're in trouble. Okay? Now let's go to the last one there on the other side. Oh, I'm sorry. We're not doing the whole thing right now. We're doing piece by piece. Yes, well, realistically, we'll do this one, and you guys will probably do the backside tomorrow. It's not hard, but it takes time to like really think about the graphs and think about the distributions. All right. For question number 4, it says for each box plot, describe the distribution of the data. So I want to know a couple of different things for all of them. I want to know, are they symmetric or not? Should I use the mean or the median for the center? Should I use the IQR or the standard deviation for the spread? And are there outliers? So as long as you have, like I said, as long as you have this page, you can really take a look at this page and see which one does your data look like. And that's going to help you figure out the distribution. So if you look at the first one, this part here, this line, that's your center. Okay? So that means your graph starts over here. It would come all the way up to the center, and then it comes back down to the other whisker. So it looks something like this. Right, here's my center. That's what your graph looks like. Now, so it starts at the end of your whisker. It goes to the other end of the whisker, and this line is where your center is. Okay, so is this graph symmetric? Or is this graph skewed? Is it pushed to the side? It's symmetric. It's a bell. Yeah. So you can write it. I'm just going to circle it. It's definitely a bell. I'm trying to show you where the center is by drawing the line. Oh. Am I going to use the mean or the median? So go back to your little graph here. Was that symmetric? Yes, so what should I use to describe the center? The mean for the center. Well, wrong page. The mean.
Oh, you want us to circle?
It's up to you. You can write the word if you want. I'm going to circle because I'm lazy right now. Okay, which one should I use to figure out the spread? Which one? Standard deviation. Which is something that we can't do by hand. We have to use a computer for. So when we get our computers, we're going to use our computers for that. Okay, last part. Are there any outliers in this data? Bless you.
No.
No, there's no data, right? The whiskers are like an even amount away, so there's no outliers. There's none. Okay, I think you can do graph B, C, and D. Work with people at your table. B, C, and D. Work on these 3 right here. Go ahead and give them a try. Just a little bit, but if it's really close to being symmetric, it's symmetric. So it's not, your data's not always gonna be perfect, but if it's close, whatever it's closest to. But again, they're like, it's close enough that I would say it's
Not like,
perfect.
I have the acting. And there is.
So you're working on graph B, C, and D right now.
So the ones that are skewed.
No, C is
Mhm.
skewed.
Pretty much, yeah.
Skewed.
Yeah, it's okay.
Yeah, whatever.
Actually, yes, completely the opposite, yeah.
And since it's me.
It's like, look at that. Like that's definitely an outlier.
Well, that was really easy.
Yeah, if you are done with that number 4, I want you to try number 5.
Can you come check it?
Number 5 is the exact same thing, you just gotta look at 2 graphs.
You have to say the outlier.
If you see one, yes, say which one it is, or give it a good, like a really good guess of what number it's close to. Because I know they're a little, it's a little hard to see, so there is one, yeah. Maybe you could also write what, if you see the mean, you could write what that mean is as well, the number for it. So it should be that center line. So just go through and once you put what the center line should be. Okay.
Where circles that?
Well, tell me what number it is. So look down and then give me about what number it is. So they count by 5. So it goes 5, 15, 25, 35, 45, 55.
Wait, so we just write on the center line.
You want us to do number 5?
I do want you to do number 5. We're going to do it in a minute anyway, but it would be great if you would do it first and give it an attempt. So it's you thinking, not just me thinking. Okay, that's easy. Yeah, so all you're doing now is you're just choosing based on
No. Another cat where I
the
was.
cell section. So you decide, is it symmetric or not symmetric? So you said, right, these two, so it's off to the side. So is it symmetric?
So you
No.
have to
Because
put
right
the
now,
line.
you're gonna use
What?
Dog, I mean dog.
center. And the IQR for this.
It's okay, we know what it is.
Right there.
I gotta explain why.
I would say yes, very close.
Oh, just say like right the one.
It doesn't have to be perfect to be close. Yeah, no, you're okay, so then just make sure too. So you're
I
telling me what the
said,
mean
I
and the
put
medians are, so you should
no,
look
this
at
cat one.
what they are. See? Yeah, just sign it. Outlier means like one that's all the way out by itself. So if you see a really long whisper, like a really long line, whatever that line ends at, right, like that one's really far away, wherever that line ends, that's your outlier, whatever that number is. That looks like an outlier to me, yeah, it looks like it's closer than the rest. Mhm.
So this means something.
Yeah, it's pretty close. It's not gonna be perfect, but I would say yes.
I did. I'm sure.
I did. It's close, it's really close. It's, look, your data's never gonna be perfect, but that is a pretty, they're all very right. I'm great. What are you telling me? Try number 5 too. The mean or the median.
The only route I saw
is
was
that, so that means it doesn't matter which one you pick, but one of those doesn't matter.
Oh.
You said it took me, that's what I did. I didn't think it dig, and I was wide open. So it was behind you.
Oh, yeah. This one's skewed, right? So if it's skewed, you have to
Oh, would
use.
say you probably have my.
You have to. So you can't use either one, you have to.
I want to find one. Will you say?
I'm only the. That's doubt it. Center of the cat on her pattern is higher than.
So you should be answering question 5 if you are done with question 4.
The center, that's not the center. Wouldn't it be the dot on number 6 is higher? The dot on 6 is higher.
The dots on the hot is
The dog on
the center is higher. So if your center is at your peak, if you go down, you're at
oh no, so
4.5. There you go. You're at a bigger peak over there. Bigger center.
so it's true basically.
I know.
You need the mean or the medium is
You said it.
The back is coming back tomorrow. Depends. We'll see how long it takes us.
That doesn't mean it's possible.
Whatever. I can't look straight on upside down.
So if this one's bigger than that.
really.
Don't you make me stop that way. What are you talking
Oh, right.
Are we done? You're finished with all of those graphs, and you've also done the bottom at the bottom. Because I'm not going to explain this multiple times. So when we have a project next week and you guys don't know what you're doing on it, I'm not explaining it again.
I'm on the question.
Good.
Either the medium or the medium is the best. It says that it seems to have some yeah.
You want to see the back?
Well, if you want to get started on it, you can.
I wish there was an app where you just take a picture of it and it turns it into an app.
That would be cool. There is a way to do it though with your computers, which hopefully I will be able to show you guys how to do that.
Well done. I have that.
It's put you have the same spread, which is 7.
Say what's.
Yes, right or left. Yeah. I have about 1 more minute there, and then we're gonna go over them.
Then mine is chosen as the measure. I assume
It's false, right? Well, that's true.
All right, let's take a look at those graphs first. And let's see how you did on those. And then we'll take a look at that bottom question.
But the other one's
Okay. So check your work with mine. If I have something on mine that you don't have on yours, please fill it in.
whatever.
All right, graph B. Graph B. It is skewed left because the tail is on the left. Because it's skewed, you're going to use the median for the center. You're going to use the IQR for the spread. And there is one outlier. So the outlier is where this long tail ends. So what I also decided to do was write where the median and the outlier was. The median is your center line right here. This is your median. Your outlier, I'm going to put need right next to it. Your outlier is this piece all the way on the left. So if you go down from wherever the number is, you should be able to give it like a good guess based on the numbers that are there. So if you didn't put those numbers in, I want you to put those numbers in. So like if you didn't put that the median was 75 and that the outlier was at 30, I want you to write that down. 30. Where? Which one? So it goes by 5s. It goes 5, 15, 25, 35. I know the numbers are kind of hard to see. All right, graph C. Again, it is skewed, but this one is skewed right because the tail is on the right. Do you guys have all your numbers written down like me too? Your median is right at the center there. It's about 37. It's not going to be perfect. You're going to use the IQR for the spread, which would be this number minus this number. I'm not going to do that. And then the outlier, there is one outlier. I said it's about 100 because it's all the way over here. And it's close to counting by 5s. So some number close to 100 would be good for that. Last one, graph D. Now I had a couple people ask me about this. Graph D is not going to be perfect, right? Your data is never going to be perfect. But if it has a very general symmetric shape, we call it symmetric. Okay? It's a little off. It's not perfect, and it's never going to be perfect. But if you have something that has the general shape, it's okay to call it symmetric. The average, again, is right in the center. Here's the mean. That's the mean right there. So I said it's about 47. And then there are no outliers because it's symmetric. All right. Questions so far on those 4 graphs? Do you think if I gave you a graph like that, you'd be able to answer those questions? If I gave it to you, if you had this paper in front of you.
Yeah.
Okay. Now, number 5. There are 2 different, yes. No outliers because it's symmetric. All right, now for number 5, it says, so there's 2 different graphs on number 5. You're going to have to actually, what's the word I'm looking for? Compare the 2 graphs. So it says people were asked if they owned cats or dogs. The data is organized into 2 histograms below. So you've got your histogram on the left about cats, histogram on the right about dogs. Now, before we even look at these questions over here, all I'm going to do is I like to always follow my graph because it kind of shows you if it's symmetric or if it's skewed. So if you're looking at the cat owners one, is that symmetric or is that a skewed graph?
It's skewed.
It's skewed. And which way is it skewed? Left. Skew just means push. What about dog owners? Symmetric. Good. All right. Now we're going to read the questions. And it says determine if they are true or false. If the answer is false, explain why. So the first question says, A, both distributions are symmetric. Show me with your thumbs. Is that true or is that false? True or false? I see everybody's thumbs. True? Both distributions are symmetric. Yes or no? That's false. Why?
Because cat owners are skewed to the left.
Beautiful. Whoa. Cat owners are skewed to the left.
My bad, that's what I meant.
Cat are skewed left.
It goes to the right, that's what I meant.
Right. So you got to be really careful with that. Because if you say, if you say the wrong, so if you say skew, that's fine. But if you say the wrong, which way
I just said not a bell.
it is, that's okay. All right, letter B. Show me with your thumbs. The center of the cat owner's data is higher than the center of the dog owner's data. Yes or no? Thumb up, thumbs down. I see a couple thumbs up. I see a couple thumbs down. Ooh. Ooh. All right, so let's look at the cat owners. Where is the center?
No, it's not.
Where should the center be?
In the middle.
No.
No, it's
The center goes to the top of the peak.
See, that's what I
And
said.
they're
So
the
it's
same.
no.
Where's the top? Where does it go?
So it's true.
So cat owners are about 6.6.5. They're between 6 and 7.
Oh.
Where are the dog owners at? Where's your peak?
4 and 5.
4, between 4 and 5. So this is true. Ooh. Fix that if you got it wrong. All right. Letter C, show me through thumbs. Either the mean or the median is the best measure of center for the two data sets. So it's okay if I use mean or median for both of those. Is that true or false? Got some of these. Okay, here's the difference, right? When it's symmetric, right? Here's your symmetric. Your mean, median, and mode are the same. What happens when your data is skewed? Are they the same? No. So you'd have to use the median, right? You'd have to use the median if you're doing a non-symmetric graph. So this is false. What?
We use mean or median.
Well, you can use mean or median if it's symmetric, but if it's non-symmetric, you have to use the median. So this is false. This is false. You have to use the median for skewed data. Have to use the median. All right, letter D. Thumbs up, thumbs down. The two sets of data seem to have similar spreads. Yes or no?
Yes. Yes.
Yes. What's the spread of both of them?
No.
Can you repeat the question?
It says the two sets of data seem to have similar spreads. Is that true or false? That's true. The spread is you take the largest number minus the smallest number.
Which is 0 minus.
Oh, other way. 8 minus 0. Yes, the spreads are the same. They go to the same numbers. So the spreads are about the same. This is true. 0 to 8 plus for both of them, right? Spreads are about the same. About the same, right? So this distance from here to here is about the same from here to here, right? You don't have one that's like, oh, 23 dogs and, 8 cats. Okay, last one. If the mean is chosen as the measure of center, then the IQR is the best measure of spread. Thumbs up or thumbs down? Yes or no? We didn't get there? Letter E. If the mean is chosen as the center, the IQR is the best measure of spread. Yes or no?
No.
Why?
Because it's,
Which one should I use instead? The standard deviation. Yes, if you look back at your little chart here, right over here, if you decide to use the mean, you have to use the standard deviation. So this is false. All right, what questions do you have so far? Questions so far in any of those? Not a single question, huh?
So we're gonna start.
I explained so great that there's not a single question. I'm that good of a teacher.
Yeah.
I don't have a single question.
Yes.
Okay. Here's what's gonna happen now.
You go back down.
Oh my gosh, maybe you should have been writing it down as I was writing it down and not been off task, right? Okay, here's what's gonna happen now. We've got just we got about 5 minutes left. So here is, don't put anything away, just wait, just stop and just listen. Here's the game plan for tomorrow. Tomorrow you're gonna do 2 things in here. The first thing you're gonna do tomorrow is this back side. This back side is straight up exactly what we've been doing. I gave you some data. Huh? It's not hard. It's data. I'm asking you to calculate the 5-number summary. It's stuff we've already done. It's not hard stuff at all. Okay? It's just a little bit of practice. So you're going to do this tomorrow in class. The other thing I'm going to give you tomorrow is I have made a discussion post for you guys on Canvas.
What do you mean?
A discussion post. So here's what I mean. If you log into Canvas, and so, can you guys stop talking, please, while I'm trying to explain? That's not an appropriate thing to say either, but can we just keep quiet while I'm explaining, please? Thank you. When you come into class tomorrow, so you're going to do this. Now, if you want, You could do it for homework and then you don't have to do it tomorrow in class. It's not a hard thing to do. But when you come into class tomorrow, here's what's going to happen. You're going to work on this first. And then the second thing is there's a discussion post. Now, I actually have to go out of the student view. When you go to the class, you're going to click on the button that says discussions. So let's get to it. Just going to click on that image. And when you get into discussions, it will not show up until tomorrow, so you cannot do it just yet. There will be a discussion that pops up. This is on Canvas. It is called Friday, August 19th, Data Analysis Discussion. On this discussion post, there's a question. It will automatically put you into a group. You will answer. There's 3 questions to answer based on some data. You're going to answer the questions, and then you are going to respond to at least one other person's post. Okay? So you're going to make a response, and then you're going to respond to someone else. Now, I realize we do not all have our computers yet. Okay? If you have a phone, you can do it on your phone.
I don't have them.
If you don't have a phone, then you're going to do it at home for homework over the weekend. Okay? Or go to the library, do something, but it's not going to close until they have it closing on Monday. Okay? So you've got some time to do the discussion over the weekend.
So we answer the questions and then.
You're going to answer the question. So what it's going to do is it's going to force you to answer the question first before you can respond to somebody. Okay? You can't respond to someone first. You have to answer the question first. And then you'll go through and respond to somebody. Now, let's think logically. You're in groups here. If you and all your friends wait until Sunday night, or if nobody responds, then like, how are you going to do your part if no one else has done their part, right? You can't respond to anybody if not everybody does their work. So tomorrow in class, the expectation is you're doing this. And then if you have an electronic device, you're doing the discussion right after. If you don't have an electronic device, then here's my suggestion to you. Do it. Actually, I'll open it today. Do it tonight for homework and then do this in class tomorrow. Does that make sense? That way it'll make your life a little bit easier, okay? Any questions? What? Oh, yeah. I'm grand. Thank you for asking. I'm ready for a nap though. Okay.
Okay, so
Very
each
good.
question we answer and then we.
So it's you'll answer, yeah. So you'll do one post answering these 3 questions. It says, which graph do you think is better? What are 2 conclusions you can draw from the graph? Does either graph tell you how many students there are? Explain. So you'll look at the 2 graphs and you'll answer those questions first in one post. And then the second post, you will respond to at least one other scholar's post with what you agree or disagree with, or it can be something like your ideas make sense, or I think you're wrong because, then that's it. Okay? All right. If you borrowed a calculator, please put it back.